All right, welcome and thanks for joining for just this, hopefully, again, relatively short examples video. We're just going through 6 slides. It's 2 slides on shifting, 2 on reflecting, and then 2 on stretching and shrinking. So we're going to start with shifting. So first off, we'll sort of walk through this as if we didn't know it was a shift. When you look at something like this, f of x plus 2, what you want to be keeping in mind is that this addition or subtraction, so adding or subtracting, those tell me that I'm doing some sort of shift. Here, we're given an original function. F of x is equal to x squared. And what we're going to do is both write verbally what shift has happened and then actually graphing it. And get used to doing both of those because I'll want you to, or will want you to, both state what is happening and then actually graph it. That way, if you graph it wrong, I still know that maybe you meant to do the right thing. So looking at these, what I'm going to do really quickly is just draw some axes on all of these so that I don't have to switch these colors. Recommend that you do that as well, although you are probably just using one color. All right, and then on all of these, I'm going to draw this original function, f of x equals x squared. So f of x equals x squared is a quadratic function, which means we're just going to have a whole bunch of these parabolas. And again, my art is a little bit shaky, but that's okay. All right, so now f of x plus 2. This plus 2 is happening outside of the parentheses. I'm not adding 2 to x. I'm adding 2 to the function. So that tells me that this is a vertical shift because I'm adding it to y. Remember that f of x is really like your y value. So I'm performing a vertical shift. And if I vertically go up 2, I'm saying vertical up. So if you want, you can say shift vertically up 2. And all we do is we take this graph, and here 0, 0 is our vertex. We're going to lift that up 2 units and draw a sketch of what this would look like. These sketches won't be super accurate. You know, we're not going to necessarily be looking for everything spot on right now. I'm just looking to see that you have the general idea of how this should look. All right, next. I have a shift, obviously, we're in the section of shifting, and this is x plus 2. So what you want to be looking at in this case is the fact that the plus 2 is inside those parentheses. It's happening to the x value. What that means is that this is shifting horizontally. And then you have to remember that things that are horizontal are often counterintuitive. So when I see plus 2, I'd usually be thinking like, oh, it's going to be a shift to the right 2, but it's actually the opposite of that. It's a shift to the left 2. So we'll just take that vertex again, go left 2, and draw our parabola. Again, up and down, that was outside of those parentheses. You weren't adding to x, you were adding to y. Left and right, you're adding directly to x, and it's usually always going to be in parentheses. All right, next. Oh, I'm sorry. This is a different function. Oh, God, you're going to be so mad. So let's erase that red line and draw new ones. I didn't realize that we switched to the function here. F of x is equal to the square root of x. So square root x function just goes like this. And we're going to perform these shifts on it. So first, we have a shift. This is subtraction directly to x. Because it's inside that parentheses, I literally can read x minus 2 inside of that. So that means that this is horizontal. And because I see x minus 2, that means I'm actually going to the right 2. So I'll just take this starting point, move it to the right 2 units, and then have my function. Here, I could read, remember that f of x is really like y. So this is just y minus 2, meaning I'm changing my y value. And the way that I'm changing it is I'm taking 2 away from it. So this is vertical, and it's down 2. So I take that little starting point, drop it down 2 units, and have that same shape. It's probably not the best, sorry. All right, some more. I know it says again on your own. I'm going to do them with you. We're going to start by just drawing in those sketches of all these graphs. So the function that we're working with here is the absolute value function, f of x equals square root x. So I'm going to start now just by putting in the absolute value function in all of these, which remember is just that v shape. That's the basic function. It's the starting function, the one that hasn't been shifted yet. And then in blue, I'll do all the shifting. So here I have f of x plus 3. That plus 3 is outside of the parentheses. It's happening to the entire y value. Sorry, wrong pen. It's happening to the entire y value. So this means that it's vertical. Vertical things are not counterintuitive, so this is just up 3. I go up 1, 2, 3, and I'll have this same V shape. F of x minus 1, that minus 1 is inside parentheses. It's being subtracted from x. And what that means is that this is a horizontal shift. And because it's horizontal, it's counterintuitive. So I see minus 1, and that means I'm actually going to go to the right 1. So I'll take that vertex, move it to the right 1. Again, we're just doing a little sketch. F of x minus 4. This minus 4 is outside the parentheses. It's being subtracted from the whole function, which means it's vertical. Vertical things are not counterintuitive, which means I'm going down 4. So I'll drop this down 4 units and then just draw that function. Remember that shifting, you're preserving the shape. These shapes, other than my art skills, are the same. I've just picked it up and moved it somewhere else. Last, we've got 2 things going on here. So this plus 3. The plus 3 is outside of the parentheses, and it's being done to the entire function, which means that that's a shift up 3 units. The plus 2 is inside parentheses, which means it's happening to x. And when you're adding to x, remember that that's counterintuitive. So this plus 2 actually tells me I'm going left 2. So I'll go left 2, up 3, and I draw my function. So that was a case where you had 2 shifts occur at once. Not too bad still. All right, moving into reflecting then. If f of x is equal to the square root of x, so just as before, I'm going to start by just drawing in these functions real quick. And I will graph our original function in red. So square root x looks like this. So when we're talking about reflections, remember that when we're looking at a reflection, we're looking at these 2 functions, and we're saying all that happened was one of the variables changed signs. X changed into negative x. Well, what does that mean? That means that all I did was changed my x value. I changed it to negative x. And again, if you're thinking about like some point in the first quadrant, let's say 2, 3. So, right here, whatever. I know it's not actually 2, 3, but that's fine. 2, 3, and all I'm doing is changing the x to a negative. So it's going to become negative 2, 3. So what did I just reflect over? Well, I just reflected over the y-axis. I would want to see this reflection over y. That's telling me that verbally you know what you're supposed to be doing. And then the graph tells me that you know what that's supposed to look like. So now if I'm reflecting this over y, I'm just picking up each one of these points and flipping it over here. Notice it's like a mirror image. Now in this case, g of x is equal to negative f of x. So it's equal to the opposite of the original function, of the whole original function. So what that means is if I put in, let's say I put in 4 here, or let's say I would put in 4 here. Originally, if I put in 4, I would get square root of 4, which is 2. Now, if I put in 4, I'm still working with the x value of 4. But what's going to happen is I'm going to have the square root of 4, which is 2, and then the opposite of that. So it would become negative. So this graph is going to go like this. It's okay if you didn't exactly follow that logic. Always feel free to just play around with some points. Okay, I think I drew the exact same thing, but this graph is just going to be in the 4th quadrant now. This is a change in your y value. Here's y, which means that you're reflecting over x. Again, the words to tell me that you know what you want to do, the picture to tell me that you know how to graph that, what it's supposed to look like. All right, now we have some sort of mixed example there. Looking at this first one, we have x squared plus 2. So all we've talked about so far is shifting and reflecting, and I'm like, is this a shift or is it a reflection? Well, I see here that there's a plus 2. That tells me right away that that's a shift because it's addition. Then you ask yourself, are you adding 2 just to x or to the function? Well, if I look at this, this is x squared, which is not just x. So this cannot be a horizontal shift. If it were horizontal, this plus 2 would have to be just to a regular x, with very, very little exception. So this is going to have to be a shift, and it's vertical. Vertical things are non-counterintuitive or not counterintuitive, so it's a shift up. As I sort of walk through that explanation, get that thought process down of like, is it in the parentheses? No, so it's vertical. Vertical things are not counterintuitive, so it's just up. Sketching this then. I'll draw this graph as well. So if I'm sketching this, the original function is just x squared. I'm shifting that now up 2 units. So I go up 1, 2. These aren't going to intersect or anything, but the shape sometimes with things that are curved will come out a little bit different. All right, g of x equals negative f of x, which is equal to the negative of x squared plus 2. So all I've done is I've taken this function, x squared plus 2, and now I'm saying I want the negative of that. So notice it's negative f of x, which means that all I did there was just, and I'm going to switch this color actually, all I did there was just changed the y value. If I was changing the x value, the negative would be exactly in front of the x. So because I'm changing my y values, what I'm doing is reflecting over the x-axis. I'm not even going to use this one. I'm still going to use it on here because it's the same function. So all I'm doing now is taking this blue function that I shifted, and I'm going to reflect it over the x-axis. This is sometimes where people might make a little bit of a mistake because they might start right here. That's not reflecting over the x-axis though. Originally, you're 2 spots away. You need to continue to start off then 2 spots away. But now instead of this opening up, I'm sort of pulling this downward. So it's going to be opening down. Again, you have to keep that sort of symmetry away from what you're starting at. Since we were starting at the x-axis, I needed to be the same units away in both directions. All right, so that's this graph. All right, and then just some examples of stretching and shrinking. And because there's not going to be a scale on these graphs, like we're not putting in tick marks, it won't be super accurate, but it'll give you just the idea of what these are supposed to look like. I'm going to start again with just putting in these graphs. That's a terrible graph, so I'm going to fix that one. All right, so we have absolute value x. And now I want f of 3 times x. So just like reflecting or shifting, I see that this 3 is being multiplied to x. By the way, the fact that it's a multiplication tells me that we're doing some sort of shrink or stretch. So I see that it's 3 times x. Because it's being multiplied just to x, as opposed to the whole function, that tells me that it's going to be something that's horizontal. Just like before with addition, you have to be thinking like horizontal things, they're not what you think. They're counterintuitive with this topic. So when I see 3 times x, I'm usually thinking like, oh, I'm going to multiply the x by 3, so it's going to get longer. But that's not exactly the case. This is actually going to be a horizontal shrink. And we could talk about more in class again why that is. But this is a horizontal shrink. And when you're talking about horizontally shrinking something, you're saying from the left and from the right, I'm going to sort of squeeze this inward. So what's going to happen is it's going to become more narrow. Now this looks the same since it's a sketch. This looks the same as what like a vertical stretch would be, because a vertical stretch, I'd say I'm going to start here and pull it upwards. All right, let's do an example of that. So we have 2 times f of x. This 2 is getting multiplied to the entire original function. That tells me that it's vertical. Vertical things are not counterintuitive. So if I thought, hey, I'm multiplying something by 2, I would be thinking it gets larger. So it's a vertical stretch. Vertically stretching something means that I'm like picking these points and I'm just doubling them. So they're going to be twice as high. Notice the 2 of these look very similar. And again, it's not to scale or anything. But those are examples, horizontal shrink and vertical stretch. Both of them are getting faster. I'm sorry, we're going to change that actually. They're getting larger faster. When I look at the y values of this, they're going to get really, really tall, really, really quick. A horizontal stretch, the opposite of this, or a vertical shrink, those would do the opposite. They'd get larger slower. And I'm going to draw it on this graph. I wouldn't necessarily recommend that you do it unless you label it. If I were talking about a vertical shrink, I'm cutting these in half, these y values, so it would be half as high. That's the same as a horizontal stretch, because what I'm saying is I'm pulling this and I'm pulling this to the left and right. So this is an example of vertical shrink or horizontal stretch, if you want to label that, just so that you don't look back at it and be like, what just happened there? All right, just 2 more examples. Again, I'm going to start off by just drawing what these original graphs would look like. So we have 2 different functions. So let me continue without remembering to put in the right function. Here we have an x squared function. So we have a parabola. Here we have a square root x. So we have a this thingy. And then looking at this, when you have multiple transformations, see here, combining transformations. When we have multiple things going on at once, we follow the order of operations. So you want to be following, if I were to substitute something in for x, what would happen first? So if I were putting some value in for x, the first thing I'd be doing is this addition. So right here, I need to deal with that first. So I see that it's addition. That tells me that it's a shift. Again, follow this logic. It's addition, so it's a shift. My next question then is, am I adding to x or am I adding to the function? I'm adding here just to x. You can read that x plus 2. I've just changed x. So that tells me that it's horizontal. Then I need to ask myself, is it left or is it right? Well, horizontal things are counterintuitive. So I would usually think plus 2 would mean right. Instead, it's left 2. Next, I'm going to look at this 1/2. So this 1/2, it's multiplication. I'm multiplying times this. Multiplication means that I'm either stretching or shrinking. The first thing I want to ask myself is, am I multiplying to x or am I multiplying to the function? And right here, this says 1/2 times f of x plus 2. So that is not multiplication to x. Multiplication to x, it would say 1/2 x. So this is going to be a vertical. And then I have to ask myself, vertical, well, it's not counterintuitive. And I'm multiplying by half. If I multiply by 1/2, that's not going to make things larger, it'll make them smaller. So this tells me that there's a vertical shrink. If you need to hear that thought process again, just rewind. So again, I'm going to go left 2. So I'm going to start off here, but this graph is going to get shrunk down. So instead of being a regular parabola, it's going to be a little bit wider. I know I'm doing it with these scratchy marks instead of one smooth curve, but it's going to be a little bit wider of a parabola because I'm squishing it. All right, for this next one, I want to change one piece of it before we move forward, get rid of this negative. So it's just going to be negative f of x plus 2. So again, first thing that I see, I have x plus 2. That's addition, which means it's a shift. That addition is being done directly to x, which means it's horizontal. Horizontal things are counterintuitive, which means I'm moving to the left. Then I'm not multiplying by anything, but I am changing the sign. A sign change means that there's a reflection. So I have to ask myself, is this negative in front of x or in front of the function? This negative that I got rid of was in front of x. This one is in front of the whole function, which means what I just did was changed the y values. And again, if you think graphically, if I'm just changing the height from a positive to a negative, I'm reflecting over x. The original case of this problem, the reason I changed it, it's just a little bit sort of stranger. It's definitely something that you guys will need to know and you'll see some examples of, but it's not your most common. And I didn't want to cover it here. So reflection over x. I'm going to shift this graph to the left 2. That comes first. And then I'm going to shift it over x. If you want, sometimes what's helpful is just to put in, okay, I shifted it to the left 2. Now I'm going to reflect it over my x-axis. So it's going to go this way. So doing that in sort of 2 steps, perfectly fine. All you need to make sure is that you're somehow labeling which one is your final one. Some people use multiple colors. Some people actually label them. Here it's a little bit tougher because we don't actually have a new h of x equals. But you'll see examples of that. We'll talk about it. All right. Again, if you have questions, make sure that you write down what you had a question on. I always appreciate you guys listening to these videos. Otherwise, feel free to get started on that homework. Not too bad, just a lot of sketching, stating what type of shift, reflection, things like that have occurred.